Okay, so for today's lesson, what we're talking about is we're calculating a mean difference. So this is a little bit different than calculating a confidence interval for a difference of means. So that's what we're going to talk about later in this unit. But today we're doing confidence interval for a mean difference. And the example in the notes says, how much does wind affect cycling times? And so they had the same group of runners, or excuse me, same group of cyclists riding the same track, the same distance on two different days. One was March 21st, 2010. The other was April 17th, 2010. And the wind was different on both days, so they wanted to see if that affected the outcomes. And so they tracked the times for each of the cyclists on both events. Okay, so we got 15 cyclists, and we have a time for their March 21st time and April 17th time. And part A, it asks us, using the table of times in minutes and seconds, find the difference in times for each rider in seconds. And what we're going to do is we're going to convert all of their times into seconds. So they give us their times in minutes and seconds. We want to convert that into seconds. So if you looked at, say, rider one, his time on March 21st was 44 minutes and 41 seconds. Well, there's 60 seconds in a minute, so 44 times 60, multiply that out, and then just add the 41 to it. You got their total seconds. And you can do the same thing for their April 17th time. And then if you find the difference between those, for what we're doing, we're just doing March minus April. If you find the difference between these two times, you should get 142. That means the difference in times was 142 seconds. Now, since it's a positive 142, right? If it's positive, which one do you think was bigger, March or April? I'll give you a second. Okay, so if it's positive, then that means March's time was larger, right? Because big minus small gives you a positive number. And then if we're cycling, right? Faster time is better. So based on that, which do you think they did faster in, March or April? All right, so since it's positive, that means March was a bigger time. And since it's a bigger time, you want a smaller time, right? So that means April was better. So once we have all of these values, we have 142, the difference between the times for rider 2 was 192, and then rider 3 was 36, and so on. We've got all of these values. What we can do in part B, and I'm going to scroll down a little bit, part B, okay, it says graph the distribution of references or differences and calculate the mean and standard deviation of the differences. Briefly describe the shape of the distribution. So in order to find the mean and standard deviation, what we want to do is we want to take all of these values, these differences in times, and put them in a list in our calculator. And so if I go over to my calculator here, I got stat, go edit, and I've already put these in a list for us just to save a little bit of time. But I have all of these differences, these blue numbers here, in list 1. And from here, I can just do stat, calc, and then one variable stat, and then mine are in list 1, and then calculate. And then I've got my mean and standard deviation. And then later down in the lesson, you're going to have to calculate a confidence interval. So from here, it's the same thing as what we did when we were calculating a confidence interval for a mean. We have a list of data, so you can either do, you're going to go over to stat, tests, and then option 8. And you can either do data. Since I already have mine in my data in list 1, I'm just going to do data, and then list 1, and then calculate. Or if you wanted, you could go over to stats, and we already know the mean and standard deviation, and then the sample size is 15, so you could do that as well. So whichever one you prefer, you can do it that way.